So today we're going to take some notes on hypothesis testing. Specifically, I want to focus on the p-value. All right. So what I want to do first, though, is give you a quick reminder. So when we're doing problems and you're faced with an issue, whether it's the average weight or height of teenagers or the percent of people in Portland who are Democrats, you really have to ask yourself when you're looking at these things, am I looking at averages or proportions? So if you're looking at a number like a weight, a height, average income, anything that comes out as just a straight up number, that is a mean. You're using mu, and sigma is your standard deviation. All right. However, when you're dealing with a percent, a proportion, 2/3 of the students like to wear grant gear, whatever it is. 60% of people are lactose intolerant. Anytime you're dealing with percent or proportion, it is no longer a basic mean problem, it's a proportion problem. Your parameter is p rather than mu. All right. So you have a p here, and your standard deviation you find using this equation right here. All right, so keep that in mind, keeping it straight between percents and numbers. Your distribution is similar. Your center is at p for proportions, and then you count out by standard deviations here. Your center is at mu. All right, just keep that in mind. So we have the basic sets for hypothesis testing. We've talked about them a lot already, or some at least. What I want to focus is on step 4, looking at the mechanics, how to find the p-value, and then really how to interpret it and make a decision of whether you retain or reject your null hypothesis. So that's what we're going to be really focusing on today. All right, so let's first look at how to find the p-value. So in hypothesis testing, we're kind of always looking at new data and deciding should we believe it or not. The other day what we looked at was ingots, the ingot manufacturing, and they were trying to reduce the number of cracks in the ingots, and the idea being that there is this great new machinery that supposedly only gets 17% cracks in their ingots rather than 20%. So it would be a huge improvement, and they've tested it on 400, and these are the results. The question is, are these real results? Is this really always true, or is it just a slight random fluctuation from what normally happens? All right. So to do that, we go for the p-value. All right. So here's the steps to finding the p-value. First, you just determine the distribution of the normal curve. All right. You've got to determine whether, again, is it a mean or proportion. Here, we're clearly dealing with percents, so I'm going to go for the proportion using p as my parameter. All right. Then you're going to draw a curve for that distribution. You can put the value of your new data on that curve, shaded appropriately. So in this case, we're trying to decrease the number. So if it's 17 or less, that is awesome. So I'm going to shade to the left. And then you're going to find the probability of the shaded area using normal CDF. And that is you put in your lower range, your upper range, the mean, and the standard deviation. So in this case, these would be the numbers that I would put in. And finding the standard deviation using this equation always. And then my drawing would look like this, and I would end up with 0.067 for my p-value. All right, so now that you have the p-value, the question is, how do you interpret that p-value? So the p-value answers a big question. The question is, if the null hypothesis were true, okay, so if we did have that old equipment for making ingots, what's the probability of observing the new data? So if we have that old equipment, what's the chance that we would get when we make 400 ingots that we really would get 70% with no cracks? And if the chance of getting that is pretty high, then we'd say, that could just happen randomly. There's no way I'm going to buy new equipment. However, if the chance is really small, we're going to be surprised. We'll say, oh my God, yikes, how could that have happened? The probability of it happening was so small that, oh my God, this must not be the status quo anymore. We must be dealing with a whole new situation. What we really have is good new machinery working well. Okay, so we're looking for that small p-value, and we're interpreting it based on what we think of as like our critical value. So what's alpha? And when I say alpha or critical value, I have 3 options, basically 0.01, 0.05, or 0.10. I can choose ahead of time what I want to focus on depending on what level of evidence I want. If I want to make sure, like absolutely surprised, blown out of my mind, really good evidence, overwhelming evidence, I'm going to choose 0.01 as my critical value, and I want to look for a p-value that is smaller than that. Strong evidence, significant results, I'm going to go with a 0.05. Weak evidence, I'm going to go with 0.1 or 10%. After that, after 10%, I've got no evidence. This is not convincing. It's likely to happen under that status quo, the old machine condition, so I'm not going to worry about it. So just to kind of summarize what those values are again for you, we've got these levels, whether you're looking for highly significant, significant, or marginally significant. All right, so once we have that, when do we reject or retain HO? Ooh, excuse that E right there. So let's say we chose our critical region is 0.05. So what we're going to do is we decide whether we reject or retain. So you just determine that critical value, which I said in this case is 0.05. If you maybe would want 0.01 if you're dealing with, life and death kind of safety or medical decisions, should you adopt a new drug. Issues of little importance, you could go with that 10%. And then you just see if the p-value is in the critical region. If it is smaller than these numbers, okay, if it's in this critical region, in that case, we're going to reject the null hypothesis, all right? However, if the p-value is equal to this or greater than, then we're going to retain the HO. We're going to stick with that HO. Oopsies. All right? So now once we've kind of made our decision, we need to figure out how to write the conclusion. How do you write a sentence summarizing all of this? So it is a little bit wordy. I'm going to ask you to state kind of 4 or actually 5 things in one sentence. The 5 things that you're going to want to have in your conclusion is the p-value, state whether you have sufficient evidence or no evidence, the level of significance, and then only if you are actually rejecting HO. If you retain it, there is no significance. You want to also somewhere in there put the alternative hypothesis and then those words reject or retain. So I've got 5 things stuffed into 1 or 2 sentences. And here's an example of doing that. With a p-value of 0.02, okay, I've stated the p-value. There is sufficient evidence, I've stated this, at the 0.05 level of significance, so I've stated the level of significance, to support the claim that average high school students send more than 10 texts a day. Okay, that was my alternative hypothesis. We reject the null hypothesis. I stated whether reject or retain. For retaining, you might do a sentence more like this with a p-value of 0.47. Stated the p-value. There is not sufficient evidence, stated my evidence, to support the claim that students send more than 10 texts a day. Again, stated that alternative hypothesis. And then my final sentence, we failed to reject the null hypothesis. Now that's a lot of wording, so just to give you a framework if you need it. Here's the basic framework for what you would say when your p-value is less than 1%, less than 5%, or greater than 10%. So here's the kind of the wording that we would use if you need a framework for doing that. Now, hopefully today you should now know from this video how to find the p-value. You should know how to determine whether to retain or reject the p-value, and then how to write your conclusion.